Hello, this is lesson 2 of the esters, fats and oils topic. We are going to be having a look at breaking esters this time. Last time I had to look at making esters, this time we're going to see what happens when we break down esters. So this is going to be quite a short lesson. Our learning intention is to watch an experiment of the hydrolysis of esters and learn about the procedure. Your teacher might show you this experiment as a demonstration in class. But we are going to certainly talk through the theory and understand what it's about. Success criteria is to identify the products of hydrolyzing an ester and describe the process and chemicals involved. So not a lot to go through. Let's get started. So properties of esters, again this is in your notes booklet. The words in bold are missing in your notes, so fill them in. Esters are usually insoluble in water. When we make esters, they end up as a separate floating layer, which means they are insoluble in water and obviously less dense than water as well. They have a characteristic pleasant smell and tend to be volatile. Now remember, volatile means that they evaporate easily. Uses of esters: they have strong sweet smells and tastes which are often fruity or floral. That means that they are used in the perfume industry as fragrances and of course as flavourings in the food industry. Esters are also used as solvents where rapid evaporation is required. So for example, if you are somebody who likes to put nail polish on, then you will probably have come across the ester pentyl ethanoate, which is used in nail polish, and obviously once the polish is applied, the ester evaporates, leaving a nice polished nail. Ethyl ethanoate is also found in glues. So, hydrolysis of esters was our kind of main point for today's lesson. What does hydrolysis actually mean? Well, we can break the word up into two parts. The hydro stands for water, and lysis means to cut. So it basically means to break up a compound using water. So this is the kind of reverse of condensation, is hydrolysis. So hydrolysis of esters, again, your teacher might show you this setup in the lab and carry out this experiment just so you can have a wee look and see it in real time. So an ester can be hydrolyzed by heating. Now this is usually done with aqueous sodium hydroxide, so a strong alkali. You can use an acid catalyst as well, but you don't get kind of full hydrolysis that way, so it's best to use a strong alkali like sodium hydroxide. And we use a condenser as shown. So this piece of equipment here, where the water goes in and out, is the condenser, which is obviously going to stop any volatile compounds from here escaping. They're going to turn back into liquid in the condenser tube. So this apparatus, this setup, is called heating under reflux. So the ester is broken down into the alcohol, and we also have the salt of the acid. Now, because we're reacting with sodium hydroxide, we end up with a sodium salt of the acid. So for example, if you were hydrolyzing methyl ethanoate with sodium hydroxide, you would produce your methanol alcohol, but you would get sodium ethanoate, a salt. So in order to separate the products, I'll just move this so you can see this, you're going to distill the solution, and that will remove your methanol, your alcohol, and then you're going to be left with sodium ethanoate, which obviously is a salt. We don't want a salt, we want our other product, which is an acid. So if you add hydrochloric acid, you're adding the hydrogen ions that will produce ethanoic acid from your sodium ethanoate. That is quite a complicated process, but I have drawn out the structures for you on the next page so that we can go through what this actually looks like in terms of the structures of compounds involved. So it's important that you know what this setup is and what each piece of the apparatus does, and that the whole thing is called heating under reflux. Okay, here's an example then. So we have methyl ethanoate here. I've drawn these, I've colour coded the alcohol part and the acid parts. Hopefully that'll make it a wee bit easier for you to see. So this is our first part of the reaction where we are reacting our sodium hydroxide with our ester, which is methyl ethanoate. When this happens, the sodium, which is a positively charged ion, is going to end up with this ethanoate ion, which is negatively charged. That is going to produce sodium ethanoate, and this part here is our salt of our carboxylic acid. The other product at this stage is, of course, methanol. So to get the methanol out on its own, we are going to use the process of distillation to separate the methanol from this salt. When that is done, to obtain our ethanoic acid, we are, like I said before, going to introduce some hydrogen ions, which are going to swap places with the sodium ion and produce our ethanoic acid. So hydrolyzing an ester is the complete reverse reaction of condensation. Rather than having two molecules come together to make one large molecule with a loss of a water molecule, this time we are obtaining our two smaller molecules back, which are our carboxylic acid and alcohol. So ester hydrolysis is an important part of the procedure for manufacturing soaps. There is a whole subtopic on soaps later on in the topic, so I don't want to go too much into that right now, but just for your information, that is one of the main uses of ester hydrolysis, especially with an alkali catalyst. So, very, very short lesson. We wanted to identify the products of hydrolyzing an ester. So if we hydrolyze an ester, we get a carboxylic acid and an alcohol that were used to make the ester. Describe the process. We have to heat it under reflux and then distill off the alcohol. And the chemicals involved are that we have to use a strong alkali for hydrolysis to take place. Hopefully we can all do that.